So 5.7 is all about integration that results in a arcsine or an inverse trig function. And so we've got a couple basic formulas. Now we'll come back to this later on in the year and we'll talk about what if it's not exactly in this form. What if the a and the x squared are switched around, or there's an x up top? So when you have something that's a little bit more complicated than one of these basic forms, you'll have to use, there's a couple things. You can use a substitution, or you can actually make a triangle out of them using the Pythagorean theorem and kind of work from there. I'm trying to remember what section it is. I think it's in chapter 8, but there'll be videos on it later on where you can do inverse trig integration when they're more complicated. But these are the basic ones, and they go with the derivatives. So a couple things that are a little interesting here is these have an a, whereas when we did like the derivative of arcsine, it would be the derivative of u over the square root of 1 minus u squared. Now, in this case, we've got an a that's kind of in there. And if you think about like doing the derivative, you might think along the lines of having this being x over a squared and then a 1 over a out back. Well, if you do a little bit of work with that, you can actually make it work to be this. So all we're really going to do is use these formulas. Now, a couple things that we need to know. If it was something along the lines of the square root of 4 minus x squared, the a would actually be 2. Okay? And then when we went through the formula, that'd be x over 2 plus c. Another thing to notice, when you do an arctangent, you get this 1 over a out front, and the same thing with the arcsecant. And then the other thing to notice is when you do the derivative of secant, usually you have the absolute value out here on the x when you do the derivative. But when you do the antiderivative now, the absolute value works on the inside. And sine's the only one that doesn't have the 1 over a. So I think simple sine to remember that there is no 1 over a. All of them obviously have a plus c at the end. If they're not in exactly one of these forms, then you really have to use substitution to get it into these forms. Or if it's far enough away, then you'll have to do one of those substitutions along the lines of using a Pythagorean theorem and a triangle to work with it. But as far as if you're actually working in 5.7 in our book, you should be able to solve all of yours this way. All right, one other thing is you might know, what about the arcsecant, or the arccosine, or the arccosecant, or the arccotangent? Well, if you put a negative up here, you could absorb that and make it arccotangent. However, you could also bring the negative out front and make it -1. So that's your kind of option there. And the plus c kind of absorbs some of that, but you can't have both of them. So I would just use these. If you have a negative, put them out front. You could be slick and use the arccosine and stuff like that too. All right, let's see what one of the practice problems looks like. So do a straightforward one really quick, and then we'll talk about some of the more difficult ones. So actually, if you think back to what I talked about a second ago, we did basically this where a would be 2. So we'll leave this one, and you can try that one on your own. This should be the arcsine. Over here, you might think, well, a is going to equal the square root of 2. That's not so bad. But then the problem is you got this 9 in front of it. You really want this to be u squared, and this is du. If it's not, you got a problem. So if this is anything more complicated than just x squared, you have to do u substitution. So you're going to let u equal the 9. Oh, sorry, u is going to be the 3x. So then over here, you have more along the lines of square root of 2 squared plus 3x squared. So then you have a u squared. You don't want to use the 9x squared because you don't want it to be du over 2 plus u. That's not an arctangent. Now, the other thing you have to notice is that it is an arctangent. It's something that you could make squared plus something else squared. If this x did not have a squared, you'd be looking at a natural log, which is later. Actually, it's not later. It's earlier. Already done that one. So anyway, there's a u, and then du is going to be 3 dx. So we plug in our dx as dx is du over 3. And then we plug everything we know in. So dx is du. I'm going to put the 1/3 out front, so 1/3 du, over, I'm going to write it as root 2 squared. And you don't have to do this, but you have to realize that a is root 2, plus u squared. Now we are in the right form. So arctangent is, well, we have a 1/3, It's normally 1 over a, and a is root 2. So don't forget to put that root 2 down there. Arctan. And it's normally your u over a again, right? Well, our u is our 3x over a, which is our root 2, and then a plus c. Now, a couple things you could do is you could rationalize it. I personally don't care. That's really the main point. All right, let's try a couple more here. Too far. All right, if you try number 9, which I'll leave to you because we'll do number 10, which is a much more difficult problem, and you're going to have to do the same thing. You're going to make this a 2x quantity squared minus 3 squared, and you're going to want to do a u equal to the 2x. And then solve for your du, plug everything back in, and see how it works out. Okay? Try that one out. See what happens. All right, over here, and this one's kind of a little bit more obvious, going to be arcsecant. This one looks like arcsecant, but we don't have this e to the 2x out front. We don't have an e to the x out here. And you would say, okay, that's u and that's another u. So if it's not quite u squared, and we're going to have e to the x quantity squared being e to the 2x, you got to do a u substitution. So u is going to equal to e to the x. If it's any more complicated than just u or x, you do your u substitution. So then du is going to be e to the x dx. Okay. So then the dx is going to be du over e to the x. All right, let's try that out. Integral of dx, which is going to be du. And now in the last problem, we put the 1 over, like, I'm trying to remember what it was, 2 or something like that, out front. You can't put the 1 over e to x out front because, well, it's a variable. You can't put an x out front. So you have an e to the x that goes in the bottom. You get the square root of u squared minus 1. And 1 is going to be our a. Now, at first glance, this doesn't seem very helpful because now you got du on the top, you get u's, and now all of a sudden we get x's. Well, let's look back up here. E to the x is u. So then we have du over, well, u square root of u squared minus 1. And now this is arcsecant almost perfect. So your arcsecant, you have the 1 over a, which is 1. And then we've got arcsecant. And then its absolute value of u, which is e to the x, which can't be negative anyway, so the absolute value is extra over a plus c. So we got a bunch of 1's in there that are not really necessary, but you might not know that until you actually talk about it. And again, e to the x is a positive number, so you could go with absolute value, but the practice is to stick with the absolute value. You could just use parentheses because the absolute value is going to make it positive anyway. So sometimes it doesn't look right, but when you do the u substitution, it brings it back in. All right, this next one doesn't look quite right at all. So if you see something like this, what you really have to do is you have to complete the square in the bottom. So if I didn't have 4 in the middle, I might say, well, that kind of looks like arctangent. So I got x squared plus, well, root 7 squared. Problem is, it's got that 4x in the middle. Now, a couple things. You want to look, is it factorable? Well, factors of 7 does not give me 4. Because if it was factorable, you can do something called partial fractions. However, can't do that. So what we're going to have to do is complete the square. Now, most people are going to try to complete the square in line. You could go over here and set x squared minus 4x plus 7 and set that equal to 0, and then complete the square using whatever rules you normally use to complete the square to put it in vertex form. If you want to do it that way, or put it in y, talking about putting it in vertex form, there are videos I put online on how to change something into vertex form. That's kind of what we're going to do. But usually in calculus, we leave it in line. So we leave the x squared minus 4x alone, and we're going to leave a little bit of room, plus 7 here. We're going to put something there, and then we're going to balance it over here. And what we're going to put here is, well, b over 2 squared. So negative 4 divided by 2 squared. So negative 2 squared, or 4. We're going to add 4 here, but we have to balance it, so we put a minus 4 here. So we have the integral of dx over, well, what we're going to do with this side is we're going to factor it. So this is going to be x minus 2, and another x minus 2, and 7 minus 4 is 3. So this ends up being dx over x minus 2 squared plus 3. So now you've got u squared plus 3, basically. Now, technically you probably want to do a u substitution because it's not exactly just u. So u equals x minus 2, but you're going to find pretty quick that du just equals dx. So minus 2 is not going to do anything for us. You get a du over u squared plus the square root of 3 squared if we're going to be nice and neat and use our formula. So now we're arctangent, so it's 1 over a, 1 over root 3, or root 3 over 3 if you want to rationalize it, arctan of, well, u, which is x minus 2, over a, which is root 3. And that is how you do it. So you're completing the square. You might have to watch a video on doing that on its own, or you got to practice that a little bit. We'll do one more right over here, but it can be kind of a tricky operation. All right, so let's do one more completing the square problem here, number 12. And this one is kind of a tricky one to even wrap your mind around how you want to do it. So the first thing that's weird is the x squared is negative. So what we're going to do is, and this almost might be easier, just do the completing the square like completely separate somewhere else. But I'll try to keep everything together. So what I'm going to do is I'm going to factor out a negative, and that'll flip this around to a positive x squared minus 3x. Alright, now I'm going to give myself a little space here because I'm going to try to complete the square in this line. So ignoring everything else, I'm just going to work on this part. So you're going to take negative 3 over 2, and you're going to square it, giving us a 9/4. So we're going to add 9/4 on the inside. Now here's the part that's a little tricky. This is really a negative 9/4. You see this? So negative times this positive, if you were to distribute that, I really put a minus 9/4 inside. So on the outside, I've got to balance it with a positive 9/4. So that's kind of tricky. You might want to watch that little part again if that was a little confusing to you. Distribute the negative and show that they will actually go back to the original equation. And always double check that. Alright, from here we're going to rearrange things. So dx over the square root of, we'll bring the 9/4 out front, minus, and then over here I'm going to factor x. Now every time you do this factoring, this breaks down into this middle number every single time. So I want a negative 3. This was a negative 3 halves in the middle. It's going to be x minus 3 halves squared. Go ahead and factor it and double check to make sure this is what this is. But that'll work. Now we actually have this in the right form for arc sine, whether we realize it or not. If we do our u substitution, it'd be x minus the 3 halves. Du is just dx. So we have the integral of dx, which is now du, over the square root of, well, 3 halves squared, that's what 9/4 is, minus u squared. Now when we use the arc sine, remember arc sine is the one that does not have the 1 over a out front. So we're going to just start with arc sine. C in there, arc sine of u, which is our x minus 3 halves, over a, which is this, well, 3 halves, and plus c. I'm running out of space here, so plus c I think will fit in there. So I mean, technically you probably want to distribute this in, so it should be arc sine. And you do both of them, so this is going to be 2/3, the reciprocal, minus 1, plus c. So that's what you end up getting.